Okay, I think it's about to get started. Can everyone hear me? I think it sounds like I'm doing good. Hello, my name is Jason Long, and I am the head of the networking organization in the physical retail technology group at Amazon. And I'm also the governing board chair for the DENT project. And today I'm going to be talking to you about what DENT is and how we use DENT at Amazon. Also, if you want to catch a little bit more about DENT, there's actually a DENT mini summit going on right now that will provide a little bit of a deeper dive on the technical aspects of DENT, as well as there will be a panel with me and the other members of the governing board that will be talking about DENT later this afternoon. So we'd love to have you join us there if you want to learn a little bit more. When we talk about DENT, we should really start with what is it? But before I really do that, a question I get asked a lot of times is, what does DENT mean? Why is that the name? A lot of people think it's an acronym. Lots of open source projects like to use acronyms for their name. There were two things we decided when we named the project. One, we didn't want it to have the word open in it. And two, we didn't want it to be an acronym. DENT is actually in honor of my favorite everyman character in literature. So the idea behind DENT was when we started it in 2019, I was looking for a solution for the physical store technology that we were building in Amazon that would allow me to take disaggregated networking and some of the benefits of open source networking and apply it to an edge use case. And in order to do that, I needed a solution that wasn't first and foremost designed for data centers. And the solutions we had in Amazon were designed for data centers. The solutions that were available in the community, most of them were designed for data centers. So we thought, okay, well, we need a network operating system for everyone else or for every man. And so that's sort of where we came up with the idea for the name. So it's named after Arthur Dent from The Hitchhiker's Guide to the Galaxy. And we use Hitchhiker's Guide themes all throughout. So our version 1 release was codenamed Arthur. Our version 2 release was codenamed Beeblebrox. We'll continue to kind of do that through. So that's where DENT came from, and that's really kind of in a nutshell what DENT is about, is how do we have a network operating system that can make disaggregated networking available for the everyman. So now that we've talked a little bit about that, we can talk about what DENT is. So first and foremost, DENT is an open source ecosystem that's designed to be able to take these benefits of disaggregated Linux-based open source networking and apply them to places where it wasn't really possible before. And so the distributed edge, which is where I operate, where our stores are, that wasn't really, disaggregated networking wasn't really an option there. And so we wanted to be able to build a community that would make that possible. And so when we started DENT, we really looked at the different networking solutions that were out there, and we found two key problems. One of them was the one I just mentioned. Most of them were designed for data centers. But the other one was that even the ones that weren't designed for data centers were only a little bit better than OEM solutions in terms of vendor lock-in. So they only worked on a particular piece of hardware, or if you had this particular piece of software, you could only use this other hardware. And if you wanted to be able to have kind of a variety of hardware solutions at your disposal, there just wasn't anything out there that allowed you to do that at the edge. And so that kind of became the fundamental premise for what we were trying to do with DENT, was how do we build a community that allows us to take these edge use cases, including the ones in my Just Walk Out stores, and get these benefits of disaggregated open source networking on a variety of different hardware solutions. And so this mission sort of outlines that and really drives what we're doing. So DENT was created as an umbrella project, and so it can have lots of projects underneath it. And so we've worked hard to try to drive, what is the mission and what is the sort of key principles for what would make a project a part of DENT. And we'll talk about a couple of those different projects a little bit later, but at the end of the day, it all needs to sort of flow together to be able to say, how do we make disaggregated networking available for non-data center use cases in a way that's optimized. Because that's the thing is, a lot of solutions are pushing their way down towards the edge at this point in the disaggregated networking space, but they were designed for data centers, and they're being sort of adjusted and adapted to work on the edge. And DENT was designed the exact opposite way. It was designed to work at the edge and to be optimized for the edge. And then you could take it and move it into a data center if you wanted to. But really, its fundamental premise was, how do we have an optimized solution for the edge? And so when we talk about an ecosystem, really what we mean is all of the parts of the value chain in networking. So we wanted to be able to come together with our other founding members. So we started the project with Marvell, with Delta, and with EdgeCore. And then a bunch of other partners came together and joined the project as well. And we have a great technical community now that's working to build this solution. And ultimately, that ecosystem is really designed to be able to allow silicon vendors, OEMs, ODMs, SIs, end users all come together and collaborate on this solution. And it's, you'll notice I don't talk about a NOS, I don't talk about switches, it's all of it. It's a solution that ultimately allows disaggregated networking for these end users. It's not just one part of that solution. And so at the end of the day, over the last 3 years, so we started DENT in December of 2019, and over the last 3 years, we've really been focused on 3 areas to really get right with our initial releases. And those 3 are open hardware, open software, and open testing frameworks. And that's kind of been the key for us. Over that time, I've been able to take and deploy now thousands of DENT devices into production, and that's all on this open hardware, running this open software, using this open test framework. And so if you go pull DENT down from the website and you use it, you can take the exact same hardware I have deployed in my Just Walk Out stores, you can run the exact same software, except I have it signed through my own CA and secure booted. That's the only difference in what I do. And then I have my own management control plane on top of it. You can use the exact same tests if you want, and within the test framework that I use, or you can also trust in the fact that we have automated regression testing. Keysight's one of the partners of the program, and they are working to take that testing framework and consistently run it through on all of the hardware and all of the software. So with that, we kind of, I talked about how DENT really is an umbrella project, so it's not just a NOS. And so in order to really kind of make sure that we protect the key principles of the project, we sat down and documented what those were. And fundamentally, it came down to really understanding what is it that drives the benefit of disaggregated networking. Like, well, why would people care? Why do we want it? And for me anyways, it came down to 3 big things. 1 is it enables cost reduction. 2, it enables a unified control plane. And 3, it allows for improved operational posture. And so these guiding principles that we've come up with for DENT are a way to say, how do we make sure that we can provide those 3 benefits to the edge use cases in a way that makes sense for them? And so when you look at these principles, the first one is about utilizing sort of a Linux-first approach, is the way I summarize that. And that Linux-first approach is what really allows us to drive that unified control plane. There is a really robust set of system administration tools out there today for Linux. And there's a lot of people in most of these edge end users that understand how to administer distributed Linux systems. So why does networking have to be different? Why can't we just enable all of that same tool chain so that those end users can apply that same set of tools that they already know how to use to their switches that are deployed to the edge? And so that's kind of the point of really that Linux first approach. And another key part of that is that so far in the industry, one of the things I noticed when I started looking at this is that most of the rest of the hardware OS interaction in the Linux world follows a particular model. And there's a driver, that driver exists in the kernel, there's usually an open version of the driver, there's maybe a closed version of the driver that you can get as a binary, but generally speaking, all hardware is enabled that way. ASICs were different. Why do ASICs need to be different? And so a key part of the project is really saying, how do we take that same mental model that every other hardware component in the Linux world uses and apply it to ASICs, and really try to drive that same process down into the switching world through just a Linux first approach. And SwitchDev allows us to do that. We'll talk a little bit more about that in a minute. And then another really big point of the DENT project is to simplify abstractions. So one of the key things I noticed by looking at the different solutions that were available before we started DENT was if you design a solution for the data center, then you're going to make certain assumptions about what resources you have available and what's important. And it might be that certain abstractions make sense in that world because you have a lot of spare compute on your switches, or you don't mind spending a little bit extra on more memory. At the edge, that's a little bit of a different story. And those abstractions can lead to unnecessary compute cycles being spent on things that aren't value added for the business at the edge. And so by simplifying those abstractions, we can do one of two things. We can either allow an end user to cost optimize the hardware down to the floor, or we can allow them to have suddenly a lot of extra capacity on their switches and routers that they can use for other workloads. And they can get cost optimization by being able to blend multiple device types together and run unique processing capabilities on their switches. Another key thing about simplifying abstractions is that it allows you to better troubleshoot what's going on in your network. When you have vendor solutions or you have a lot of user space abstractions, a lot of those can end up becoming like black boxes that you have to go to the vendor or whoever wrote that code and have them help you troubleshoot. You can't do it on your own. With a Linux open first approach, all that source code's available to you. You can go look at every bit of code that's running on your switch, and you can trace exactly what's happening all the way through whatever data flow you're analyzing. And that comes with it an immense amount of power and an immense amount of flexibility. It requires that you rethink the way you operate your networks. But if you do that, and if you sort of retool the way you approach your network, then you'll find that you have this amazing ability to be able to go look at all of the aspects that are running on your switch and really start to get into the root of what's going on much faster. And outside of that, if you, I'm jumping around just a little bit, but if you have a community around you, then as you look at that source code, if you need some help, you can go to the community, because that community is all of the different components of the networking supply chain. If it's a hardware problem, there's someone on the hardware side that can speak up in the community. If it's an ASIC level problem, someone in the ASIC community can speak up. If it's some sort of user space software problem, that's in the community as well. And so you don't have this single gatekeeper. If you want to, so one of the things that we're developing in the project is the ability to have third-party support. So if an end user wants a single gatekeeper for support that they can go to, great. They totally can. But for me at Amazon, I don't want a single gatekeeper. I want to go to whoever the problem is. I want to be able to find it myself, and then I want to be able to fix it myself or recommend the fix to whoever owns the code. And the DENT project is really the only thing I've seen out there that really allows me to do that in a way that's optimized for the edge. And so I think, with all of these different benefits that we're trying to drive, one of the other really key principles for us is to keep focused on this distributed edge and make sure that we don't get distracted by trying to go to every use case under the sun. DENT absolutely can scale. We have plans in the governing board to add additional use cases over time. But first and foremost, we're really targeting the feature sets that are required for this distributed edge. And I'll talk a little bit about what that means for us at Amazon and how we've used that. But what it's done is it's let us simplify the feature set that we need available from day one and the feature set that we've tested, and make sure that that's robust without having to have the kitchen sink of enterprise features or something that might be required. One of the dirty little secrets about DENT is that I tell my team all the time, it's just Linux. So the reality is that if you can already do it in Linux, you can probably do it on DENT. It's just if we don't say that it's a feature available in DENT, it's because we haven't tested it. But it's all open source. You can go try it. It probably will work if it works in Linux. So Kind of very tactically, what that means is really we're focused on standardizing silicon and switch software. We're using SwitchDev to do that. And then we've sort of broken the project up into these phases. We're well into phase 1 right now, like I've been talking about with the distributed edge. With our 3.0 release, which is targeted for January of next year, we're going to start adding some features that get us into some other use cases, things like IPv6 parity with IPv4 and port isolation. We're starting to add some QoS features that will come in a 3.x release. So we'll continue to kind of drive into that phase 2. And then I mentioned it a little bit earlier, but in parallel, we're working on phase 3. We decided to kind of do those in parallel and are working on third-party support opportunities. So we have multiple partners like Sartura and Aviz and Keysight and Delta that are working on developing support programs for end users that need some help either with integration with DENT or with operational support after the fact. So we'll kind of pivot now to how are we using DENT at Amazon. So I think the first thing to do, this is where I'm going to do a little presto changeo. If you aren't familiar with the Just Walk Out technology, I figured I'd show you a quick video. Hopefully this works. Oops, it didn't work because I have to get it over there because I forgot I have to close the show. Let's try this again. There we go. Okay, so this is one of our third-party Just Walk Out stores that we've opened with Hudson.
Hudson is one of the leading travel retailers in North America with over 1,000 stores company-wide. Hudson Nonstop is our first contactless store powered by Just Walk Out technology by Amazon. This is the Dallas Love Field Hudson Nonstop store. It opened in late February. It was the first nonstop store to open in an airport. It's a little under 500 square feet and one of many to come. Customers are more and more looking for contactless ways to shop. They simply scan or tap a credit card to enter the store. That creates a virtual cart for the customer. The customer goes around the store, selects the items they want. If they don't want, they can either set them down or just put them right back on the shelf. As they exit the store, their credit card is then charged for those purchases.
The response has been incredibly positive. People are very intrigued by it. How does it work? How does it know what I'm getting? How am I paying for it? Just walk out.
It was very seamless. You come in, you choose what you want, and you walk right out.
Fast and easy, fast and easy. Didn't have to worry about, ringing up or any of the time-consuming things.
I've never seen anything like it before.
The innovation serves our customers in a variety of ways. First and foremost, people want to get in and out of an airport store quickly. We obviously give them the convenience of the waters, the snacks, the travel items, but we also have the ability to offer things that they didn't know they were looking for. High-end electronics, souvenirs, a gift to take home, or something that they just picked up on their way. This technology has changed our employee experience. We have turned our cashiers into customer service associates. They are now there to engage the customers, to help them with their shopping experience, and really it's more of an interactive process. The partnership with Amazon has been very, very productive and very easy. This technology gives us a competitive advantage. People are looking for this now and they're coming to us trying to seek us out. But the support from the Amazon team was incredible. From training, through store construction, through setup, Amazon partnering with us the entire way. This Hudson Nonstop concept with the Just Walk Out technology has given customers and employees in the airport something to look forward to. It's new, it's different, it's innovative, and it's nothing they've ever seen in an airport before.
So that gives you a little taste of what it is that we're trying to provide at the edge. And so if you think about what you saw in that video and what's making that shopping experience possible, it's a whole host of digital cameras, wireless access points, electronic shelf labels, wireless weight sensors. You may not have noticed it, the device that they were putting their credit card into to enter is also a biometric device that uses a technology we have called Amazon One. There's entry-exit gates, there's edge compute devices that drive all of that. And when we fuse all these signals together. We send them to processing devices in the store or processing systems in the cloud, and that's what enables these customer experiences. We can identify the users, we can figure out what shopping activities they had, and we can ultimately enable that grab-and-go shopping experience with the automated billing in the back end and updating inventory when things happen. And this is all a massive amount of data that gets generated at the edge. Every one of those devices is PoE powered, it's data connected, it's streaming huge amounts of data. And how do we do that in a way that's cost effective for our customers? So Hudson is one of our customers and they want a cost effective solution. So how do we make that available in a cost effective way? And so just another look at that same problem. You'll take a store that, is maybe anywhere from 500 to 40,000 square feet, and there could be hundreds of cameras, tens of thousands of labels and sensors, point of sale devices. You're talking thousands of devices that are all connected to the network, that need to stream data, that need to be able to track what's going on, that need to get power. That's a very different networking problem in retail than we've ever seen before. And so DENT has allowed us to really be able to provide this cost-effective way to solve this problem. And so every one of those devices behind the scenes has a DENT switch connected to it. Some of those devices are even running DENT. So because that's one of the other things that we realized pretty quickly is that DENT provides not only a unified control plane in our network, but it also allows us to take a lot of the benefits that we've driven on our network infrastructure and apply it to other parts of our infrastructure. So today I run an IoT gateway that drives some of the sensor devices. I run DENTOS on that. Those entry-exit gates that customers authenticate into, I run DENT on that. And it's allowed me to unify the management plane. It's allowed me to unify the processes I have to go through to harden those or to update those or to operate those across the board. And then the final layer that it did is that I was able to go look at the places where there was a hardware commonality across those different devices and drive hardware use cases across all of them as well. So I'm using similar components in each of those device types, and then I'm driving them with the same drivers and with the same OS that uses the same applications. And so it's allowed me to get all of that to market really fast. And so just to give you an idea of speed, we started DENT in December of 2019. We released the first version of DENTOS and our first DENT hardware in December of 2021. No, sorry, December of 2020. In January of 2021 is when I did my first production deployments of DENT. And then we released DENTOS V2 and additional hardware in March of 2022. And now I'm at the point where I have thousands of different devices in production today running DENT, doing all of these different things. And so what has that done for me? At the end of the day, it's allowed me to lower my OpEx, so it takes a lot less effort to be able to manage these networks, to be able to deploy these networks. It allows me to utilize the same resources for the different types of devices that are in my store. It's dramatically lowered my CapEx. So I was using a commercial disaggregated network solution prior to DENT, and switching to DENT allowed me to drop my costs of hardware by about 50% across the board. Because of that simplification at the end of the day, opening up additional hardware types, decreasing resources on the boxes, and driving cost reduction. And then it allowed that reduced integration time and allowed me to get this into production with brand new hardware running a brand new operating system, brand new control plane, all deployed into production in just over a year. And so really that kind of, I've talked a little bit about DENTOS. So DENT as the umbrella, it has the hardware component, it has the operating system component. DENTOS is one of those operating systems. It's the one that I run, but there is the possibility inside the DENT project to run, to have other operating systems that all follow the same guiding principles, but at the end of the day, maybe are a slightly different build if an end user has a desire for something a little bit different. But if you use DENTOS, and really just about any OS in the DENT project should have these same benefits, and no SDK licensing, community driven, an automated software test bed that you can rely on. And so I think I mentioned earlier, so DENT 3.0 we're hoping to release, or DENT OS 3.0 we're hoping to release in January of this year. So we'll continue to invest in that ongoing development. And with that, I think that brings me to the end of my talk. So what questions do you have for me? Yeah, and I'm supposed to use a mic.
You mentioned collaborating with multiple vendors, silicon vendors, and you mentioned Marvell. Have you gotten? Have you reached out to Qualcomm, Intel, other switch providers? What's the enthusiasm you've heard from?
So it's kind of an ongoing thing that we're working on right now. We actually started the project with Marvell and Mellanox as founding members. When Mellanox was acquired by NVIDIA, NVIDIA decided that they didn't want to participate in the project anymore. So DENT will run on the Spectrum ASICs from NVIDIA as well. So NVIDIA has continued to maintain their SwitchDev driver support. And if you go look at the hardware compatibility list on the DENT website, it lists at least one Spectrum box that is tested. But like I said about Linux features, you can basically run DENT on any Spectrum box because Mellanox has SwitchDev drivers for all of them. It's just we haven't gone through the process of testing every single one of them after they left the program. Outside of those two, we have sort of continued in ongoing conversations with other silicon providers. So I think there are both big and small providers in the ASIC space that are showing interest, and we're continuing to have conversations. No announcements we can give yet, but we're continuing to drive more and more hardware opportunity or hardware options. The other thing we're looking at, I mentioned the benefit of driving the same OS across all these different devices. And so one of the things I'm looking at inside my own network right now is how could I get DENT running on an access point and have the same benefits I see with the ASICs, but do it in the wireless space. And so we're talking to Qualcomm about that. We've been talking to NXP about the CPU side. So we continue to have all of those conversations, and we'll drive as much of that forward as we can. But no announcements. So
just a follow-on on that, what are the barriers for adoption to the vendors in terms of software? Is it upstreaming? Is it getting to SwitchDev? Like, what are the barriers to getting more adoption?
So I think there's probably two big barriers. One is end user involvement. So this is the first time I'm able to talk publicly about the way I'm using it. So DENT's been growing really slowly. And so, like anybody in the supply chain, they want to know that if they're going to go do development work, they're going to see revenue from that on the back end. So the more the community grows, the more demand there will be for DENT devices and SwitchDev driven devices. So that's the first big one. The second big one that we're working through is that a fundamental component of using a Linux first approach is that you have to upstream everything into the kernel, and that's a slow process. And so we're working through that. We're looking for ways to accelerate that. We're working with the LF to be able to drive sort of the right engagement to continue to be able to increase the velocity of upstreaming into the kernel. But that is a barrier for a lot of hardware vendors who don't have any experience with that. Yeah, thanks.
Thank you. Yeah, my question was around software. So what is the story for, let's say, a developer writing software for DENT from the time of writing it to distribution, then to runtime? Can you talk a bit more about this aspect?
I mean, it's just Linux, right? Yeah. So at the end of the day, you can write what you want. I mean, in my environment, I've taken things like AWS CloudWatch logs agent and metrics agent. I've taken AWS SSM. I've just deployed those agents onto the box. We have a whole sort of code management tool chain inside Amazon that we use, and we're able to leverage all the same tools that we use to write software and deploy software onto our Linux hosts to get them into the switches. The only difference we have to do is figure out, okay, our Linux hosts are mostly in data centers and have a certain set of understandings about how the management of those devices work. And these switches are all at the edge. So we just have to write a layer in between that allows for safe deployments to the edge. But it's like any other Linux development. At the end of the day, the mental model that I tell every developer on my team is you should think of a switch as a Linux server with a whole lot of NICs. That's it. And you write software just like that.
Okay. And is it all container-based or not necessarily?
It's not, and this is a choice that we made from an architecture standpoint. I mean, again, it's Linux, so you could deploy containers on it if you want, but in order to optimize the hardware, we wanted to remove the resource drain that the containers did, and so by and large, we do sort of single-purpose deployments onto the boxes and try to limit the amount of use cases as much as possible. We are working on a project right now that will sort of converge multiple use cases together, and we're considering looking at containers for that. But again, you can make that choice. Like, it's just a base bare metal Linux box that's running, and if you want to run containers on it to be able to do virtualized functions, that's all open and available to you.
Thank you.
Absolutely. There's one up here.
So clearly the focus here is on the networking side of things, but you mentioned that you also have edge compute happening inside these stores in this case. Are you looking at trying to unify that and use DENT there as well as the baseline for it? Or?
We are, yeah. So I think at the end of the day, the general mental model is any device that needs to run at the edge that uses Linux can and should run DENT. We've sort of taken a very deliberate approach to how we go about doing that, because one of the key strategies that Amazon uses for rapid development is to create teams that sort of are single-threaded and own their space and can develop solutions within their space. And so we have my teams that own all of the networking things, and we have a different team that owns the edge compute devices and software. And so as we develop those solutions in parallel, we continue to talk about opportunities to collaborate, but there's no company-wide mandate to force a single solution. So we continue to look for that optimal time to drive that together. We were able to find that on the IoT gateway and on the access devices, but the development on the edge compute continues to go at a really accelerated rate, and it hasn't allowed us to overlap yet, but that's absolutely a goal.
Okay. So my other question was, so you described that it sort of fits in with the CI/CD pipeline you have at Amazon, but have you looked at sort of making that driving the stuff through some APIs so you can get more common sort of orchestration and whatever pieces across industry? Is that something that's interesting, or?
It is. I think from our perspective, the key use case for us is to leverage existing AWS tooling. So SSM is kind of the internal tool. It's publicly available, and it's something we use internally. And so it works really well for us to align with kind of that common set of AWS tool sets. And we're talking a bunch internally right now about ways that we could contribute how we've gone about and leveraged AWS tools and AWS services to manage our networks and to manage the CI/CD pipeline. So we'll look for, we may publish a blog post or something, or a white paper that describes how you could go put together the different AWS services that we've done to be able to manage that. I think from a project perspective, we've absolutely talked about looking at other industry solutions for how to do CI/CD, and I think as other end users come into the project and look for those types of integrations, then we'll see more and more engagement at the project level with those.
So right now the user case is mostly on the edge side. Do you consider extended to like a high throughput, low latency user case, for example, the data center network, or like even customer on-prem data center?
Yeah, so I think the answer is sort of yes and no. I think it absolutely can extend there. It's really a question of picking the right solution for your use case. And so we've really focused on what are the unique requirements and challenges at the edge. And if there are unique challenges and requirements in on-prem data centers or high latency or low latency, high throughput networks that aren't solved by other solutions, then I think DENT actually becomes, because of its simplicity, becomes a really interesting opportunity there. I think that would be something we'd really want to see an end user with that use case come join the community and provide those sets of requirements and talk through what that might look like.
Gotcha, thank you.
Mm-hmm.
Just Walk Out it's an awesome edge compute IoT use case for retail. It seems like AWS Outpost is more of a generalized, infrastructure for IoT edge compute. Does Outpost ship with DENT?
It doesn't today, and it's for the same reason I just described. So the Outpost team developed sort of in their single-threaded silo. We've developed in ours. We've had conversations with the Outpost team about the value proposition of DENT in the Outpost racks.
Yeah.
And that's a thing we'll continue to talk about. But again, it's that same like finding the right point to intersect because we don't have this company-wide mandate to drive sort of single solutions across the space.
Yeah. And does Outpost ship with Cumulus then, or what is it running?
No, so Outpost ships with other solutions that I don't think are public, so I can't talk about. But it's not it's not DENT, it's not Cumulus, it's other solutions.
Got it. Thanks.
Yep, I think there was a. Oh, okay.
So look like this was the optimized Linux kernel system for network, right? So can you talk about if there's any like a trade-off made in here in your solution?
Yeah, so I think the biggest trade-off we're making by really leveraging the kernel is the slowness of upstreaming. So a typical model for network operating systems in the past has been that you go with probably not even the most recent stable long-term support kernel. You're multiple kernels back. And because of the fact that SwitchDev relies on SwitchDev drivers developed by the ASIC vendors that are upstreamed into the kernel, we're always having to move to the latest kernel. And we have a sort of key principle at the project level to not have to patch the SwitchDev drivers into the OS at build time, and instead work to actually get it fully upstreamed into the kernel and available. But that means that as a project, and as an end user, we have to be willing to take on that overhead of basically every time there's a new kernel, we have to go through the process of bringing that new kernel in, making sure it's fully supported. So it's sort of a give and take. It's really nice because then we have a lot of things available to us that aren't necessarily available in other solutions because they're the latest and greatest in the Linux kernel, but it has a decent sized overhead attached to it that we've had to take on as a project. And then there's just the mechanics around how do you get fixes that need to go into the kernel pushed through quickly. And so from a production standpoint, I've had to decide that, I'll build a system that can patch the kernel as long as that particular patch has been upstreamed and we're just going through the process of getting it merged into mainline. But then so that I can, maintain sort of my deployment health, I'll go patch it in for my own deployments. Can you use the mic?
Is there any impact on application developers? So something in Linux kernel was removed?
No, so this is one thing that I think is really dependent on how you approach it. So at the base of DENT is Debian. So we used the ONL build system as the starting point. So it builds a Debian-based system. So it's actually a full-featured kernel that you're not sacrificing anything on. But as we look at opportunities like maybe the wireless use case or whatnot, where we are looking at ways to build more optimized versions of DENT that won't necessarily have all of that available. But as of today, there's nothing being sacrificed. My developers are able to do whatever they want. The only thing they have to think about is what are their resource constraints. And so, they look at how do they optimize, what language they're using and optimize their code to use the resources as efficiently as possible. Cool. What other questions?
So what will be the role of system integrators in DENT ecosystem? For example, can any system integrators build their own solutions without Amazon services?
Absolutely. So DENT is used with Amazon services in Amazon. DENT is not tied to Amazon services in any way, shape, or form at all. And so a system integrator, I think the number one role that a system integrator plays is that most of the target end users that are out there at the distributed edge space aren't going to build this themselves the way I did. They're going to need a system integrator that's going to help them figure out how to pull all the pieces together, tie it into an existing control plane, or maybe bring in some other open source control plane that they can use. And that's the role the system integrator plays. And the system integrator can do that in whatever way they want. They're, one of the member companies on the project is Sartura. They have a management system and a build system that they've brought to the table that customers can come and pay them to have the benefits of those solutions on top of what DENT provides. But system integrators could do that. They could build a bundled solution. They could go take some other platform that's out there and make that available. Depending on the level of desire from the system integrator, they could even work with the ODMs to come up with custom hardware platforms that meet some specific need that some end user has that doesn't exist in the community yet. None of that is dictated by anybody else in the project. And so you could come join the project, you could start to contribute from a technical perspective, and then you could start building sort of your version of a product offering around DENT in whatever way you see fit. And AWS products are available, so if you want to use AWS products to do that, great. I can probably give you some pointers on how I did it, but you can go any other route you want. Any other questions? Yeah. Thanks.
Yeah, this is a really interesting project. It seems like you've reinvented the appliance. And it's sort of special purpose appliance in this particular case, although I can see other use cases for it. And I'd be curious about the long-term viability of supportability, as in service supportability. I come from telco, so obviously that's something we are very concerned about.
Absolutely.
So just if you could make some comments about that.
Yeah, so I think this is really where it depends on your view of the networking world. So what I did was I decided that I was going to go all in on disaggregated networking and open source, and I retooled my whole team. And that retooling allowed me to get all the benefits from an operational and supportability and long-term sustainability perspective. So I have kernel developers now that can go in and deep dive code that's submitted by ASIC vendors and can go write new features. And I have software developers that can manage all the different layers of the stack. And I have network development engineers that understand how routing in Linux works. And if you're willing to do that, then the long-term viability is unending. Like, it's Linux. Linux has proven it's going to be around for a long time. The Linux networking stack is incredibly stable and will continue to get developed. And that's what this is all based off of. This is where I think the other place where service integrators come into play is because if you're an end user who doesn't want to do that, but you want to go work with a service integrator who's done all that for you, and then you can figure out which part of that system you want to interact with. Maybe, I also go talk to the ODMs and I design my own hardware. Maybe you don't want to do that, but you're okay with working with an open source NOS, and you can go figure all that out. That you can absolutely go down that path and have a very long-term viable approach, as long as you have somebody that can help you with the hardware side. And you can look at kind of all of the layers of interaction with the solution. And that's what we're trying to build with the ecosystem is that any end user could come in and say, okay, I want a turnkey solution provided to me by an SI that I don't have to think about. Or I want to build it all myself, or anywhere in between. And all of those, because at the core, they're built on things that already exist. Like, I didn't do anything new with DENT. All I did was put it together in a way that hadn't been put together before. And so because of that, I think I don't have any concerns with the long-term viability of the solution or my ability to support it in production.
I was just sort of thinking of, and I have personally had this experience with having built an appliance. Over time you get, different versions of hardware out there. You get different versions of the software, so the controllers aren't synchronized correctly. And
Yep.
There's a lot of just crud that creeps into the system over time. Yep.
Yeah, I think that's actually an interesting management problem that distributed edge has in general. And the way I've chosen to solve that, I think DENT enables, which is, I just look for software solutions. At the end of the day, I need software that obfuscates all of those differences and makes sure that it can figure out what needs to happen on all the different devices. And it's why I've approached sort of my solutions from the perspective of saying, at the end of the day, as many of my problems that I can move from hardware to software, the better off I'm going to be in the long term. Excellent. Any other questions? Great. Well, thank you very much. It was a pleasure to talk to you all.